Question 16, find the surface area. So we have what's called a composite figure. It's made up of two figures that we can identify. We have a cylinder right here, and then we have a cone on top. So the first thing that I'm going to want to do is write out the formulas for each. So let's start with the top. Let's start off with this cone here, right? The surface area, oops, grab my pen. The surface area for a cone is equal to slant height times pi r plus pi r squared. Pi r squared is the circular base. Right? And the S, the slant height pi r, is this rounded area, okay, the side. So let's also talk about the surface area of a cylinder. So the surface area for the cylinder, okay, we know a cylinder is made up of two circles, so 2 pi r squared plus that rectangle that's rolled up. We've talked about this in previous lessons, which is 2 pi r, the circumference of the circle, times h. Okay. Now, this question is tricky because normally when we have composite figures, when we're working with volume, a lot of times we just find the volume of one and the volume of the other and we add it up. Well, with surface area, it's a little different because remember, surface area is like wrapping paper. How much paper do I need to cover this figure? And if I calculate the amount of wrapping paper that I need for this top part, this cone, as s pi r plus pi r squared, I actually have extra paper because this pi r squared is the circular base, and the circular base is inside the figure. I don't wrap the inside of a present, I only wrap the outside of the present. So I'm actually going to eliminate that portion from my formula because I'm not wrapping that piece, right? That's inside the figure. And along the same lines, I'm not going to wrap this top circle of the cylinder. So instead of having two circles to take care of, I only have one. Okay, so I'm eliminating this bottom, the base of the cone, and I'm eliminating one circle from the cylinder. I don't want to eliminate both because remember, the cylinder has two circles. There's a circle here and that needs to be covered. So I'm going to put this information together in one equation that's going to work for this particular problem. Okay, so the surface area of this figure is going to be slant height times pi times the radius. Okay, that's this right here, plus the circle here, pi r squared, okay, plus 2 pi rh. Remember, this h is the height of the cylinder, which is this right here. Okay, so it looks like we're going to have a little work on our hands. Starting off, S, the slant height, that's the slant height of the cone. Okay, so it helps me that we have these lines drawn in, right? This is the slant height here. So we actually have a right triangle. We know that this is 4. We know that this is 7, right? Because this matches this here. So this is 7. So I can find my slant height by doing Pythagorean theorem. A squared plus b squared equals c squared. This is the hypotenuse of the right triangle, so it has to be c. So we're going to use the Pythagorean theorem to find slant height here. Okay, so let me erase that. Let's move on to the next part of our equation. Okay, oops. The next part is the radius. Well, the radius, right, of this circle is given. It's 7, right? So that's easy. We just plug in a 7 here. Okay, plus pi r 7 squared plus 2 pi 7, right? That's the radius, times the height. And we are told how tall the cylinder is, right? That's this, how tall it is, and that is 8 feet. So really the only extra work that you need to do is going to be for the slant height here. And that's easy enough because we'll just use Pythagorean theorem. Good luck. Check your answer and let me know what you get.